Hi, in this example, we're going to go ahead and use the empirical rule to determine some information about an application. So the Acme company manufactures widgets. The distribution of widgets is bell-shaped. The widget weights have a mean of 49 ounces and a standard deviation of 4 ounces. So let's go ahead and use the empirical rule, and the suggestion is to sketch a distribution in order to answer the questions. So recall that with the empirical rule, that 99.7% lies within 3 standard deviations of the mean, and 95% lies within 2 standard deviations of the mean, and 68% lies within 1 standard deviation of the mean. So drawing the bell curve as I did below, and notice that I put a mean of 49 ounces and a standard deviation of 4 ounces. So the highest point on the graph is the mean, which is 49. And if I add and subtract 4 ounces, I would get 45 and 53. And that would be 1 standard deviation from the mean, which means that this is 68% of the data that lies within 1 standard deviation of the mean. In our case, it would be widgets. If I cut this in half, that means 34% will lie on this side on the left, and 34% lies a little bit on the right. 2 standard deviations from the mean is 95%, which gives us the widget ounces of 41 and 57. And if I go ahead and find that little tiny percentage from the 34% to the 95%, I would get 13.5%. 3 standard deviations from the mean gives us 37 to 61, and that tells us that 99.7% of our data lies between 37 and 61 ounces. And this little area from the 95 to 99.7% is 2.35%. So let's go ahead now. We're all set up. We sketched the graph with the percents using the empirical rule. Let's go ahead and start answering the questions. Part A says 99% of the widget weights lie between, well, 99.7% we said was 3 standard deviations from the mean. So here it would be the green, right? 1, 2, 3. And those endpoints are 37 and 61 ounces. For part B, they ask us what percentage of the widget weights lie between 45 and 61 ounces. So here I'm given the ounces, which is 45 to 61, and I need to know the percentage of widgets between those 2 ounces. So I'm going to go ahead and just add up all the percents in between 45 and 61. Of course, there are multiple ways of doing this problem, but I think it's just easiest to just see 45 to 61 and add up all the percents. So that would start with 34% plus 34% plus 13.5% plus 2.35%. If I add those all up, I'll get 83.85%. Moving on to part C, it asks what percentage of widget weights lie below 57. So notice I'm getting a number of ounces again. Here's 57. And everything below, everything, including beyond 37 ounces, meaning all the way out here. Well, there's something I know about the bell curve. I do know that the entire percentage under the bell curve is 100%. And what this means is that the lower half of the bell curve is 50%, and as well as the upper half is 50%. So I could just take the total lower half of the bell curve, which is 50%, and just add it to every percent from 49 to 57, which would be 34% plus 13.5%. Adding those all up, we get 97.5%. So in order to answer these questions, you are encouraged to always sketch the graph. Draw the bell curve, start with the mean, start adding and subtracting standard deviations 3 times to the left, 3 times to the right, and mark these percentages under the bell curve. Then the questions are quite simple to answer.